Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. Hello once again, our most developed student. My name is Confident again and welcome to this continuation, and we are still looking at the work that will be done in your term 1 for grade 9s, and now we are looking at this part which is exponents. So we're focusing on exponents. So let us look at this topic called exponents and lay some bit of foundation. And remember, this is the ultimate guide to your grade 9 term 1 work, and we are looking at what you are expected to know in that. So if we're looking at exponents in this case, and we are saying what are the things that one expects to know concerning exponents. So we are saying when you're dealing with exponents, what you need to know in general, we've got the coefficient. As you can see, this 2 here is the coefficient, and then x to the power a. So that's why we call it x the base, and then the whole x to the power a, we call it base to the power a, and then a is the exponent. So in brief, so if I say 5x squared, for example, you see 5 in this case becomes the coefficient, x squared is base to the power of 2, and x there is that particular base. So what is it that you need to know in general with the law with the exponents? Exponents are based on laws. So I'll emphasize that whenever you're dealing with exponents, you need to understand the laws. So there is the first law of exponents, which is common to say. You did this in grade 8, but let's recap again. This is the law that involves multiplication. Now, whenever you're applying this law, there are a few rules that I need you to always be careful of. The first one is that the bases or the base must be the same so that the law can work. For example, they are giving an example: a to the exponent m times a to the exponent a n is equal to x to the exponent m plus n. Now look at this law. With this law, if I'm saying a to the exponent m, I need to multiply, not add, not divide, not subtract, but only it applies when there is a multiplication. If I find another a, it has to be the same. These are the bases. See, the base is the same. It doesn't matter. It can be n. Then it says you take that base and then you add the exponents, which is m plus n. So of course there are examples that they've given, but I'm going to be working them with you. If they say here 2 to the power 5 times 2 to the exponent 2, and then they say you need to use the laws of exponents. Now, before you use the law of exponents, let's use our calculator here just to say what will the calculator give us in that. So if I say 2 to the exponent 5, and then it's times 2 to the exponent 2, what do I get? I'm getting 128. So my answer here is 128. I'm just putting it like that. But now with exponents, then if I was not using exponents, 2 to the power 5, remember, is same as 2 times 2 times 2 times 2 times 2. That is 1, 2, 3, 4, 5 times 2 to the power of 2 is 2 times 2. So which means 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2. This is same as 32 times 2 times 2, which is 4. So we are saying 32 times 4, that's where we get 128. You see that? But that's a long way, because if they can say 2 to the power 100, you can multiply this thing 100 times. Times maybe they say 2 to the power 100 times 2 to the power 50. It will be very difficult for you to multiply that. But now that's why the laws come into play. So what are they saying with the laws? With the laws of exponents, who are saying you get that 2, you identify the base is the same, so you add the exponents, which is 5 plus 2. What is 5 plus 2? Is 2 to the power of 7. Now 2 to the power of 7, that's 128. You can then use your calculator to simplify that. Alright, so that is using law 1. Let's look at this other example here. They are saying here 2 to the power of 2 a dot 2 to the power of 5 a squared times 3. So this is I'm supposed to use the laws of exponents here, but remember, whenever you're using the laws of exponents, you can regroup these things together, whereby the bases that are similar, they come together. For example, I've got that 2, which is 2 to the power of 2 times, you can put a times there, 2 to the power of 5. Remember, dot and times is the same. Now if it's 2 squared a, it means there is a hidden times there. Are you with me? So in this case, this is same as saying 2 squared times a, but now the power for a there is 1. You see that? Times, that dot can be times 2 to the power of 5 times a squared times 3. Do you see what I'm trying to say? That's what actually this whole thing it means. So if I can continue, therefore it's 2 squared times 2 to the power 5. You bring them together, which is this, you rearrange. That's what I'm doing. And then you focus on a, which is times a to the power 1, and that one is times a to the power of 2. And then with that, the last one left is times times 3. Okay, so you have covered that, everything is there, and then we apply our law. But our law, remember, works with bases. If the base is the same, you apply the law. So here we'll say 2 to the power of 2 plus 5 times, again we apply the law there, which is what? A to the power 1 plus 2 times 3, which is equal to 2 to the power 5 times a to the power of 3, which is 1 plus 2 times 3. Okay, now remember, 2 to the power 5 is, you can use a calculator at this stage because they assume in a way you know what is 2 to the power 5, so they won't penalize you there. So 2 to the power 5, because anyone can know what is 2 to the power 5, is 32. So you're going to say 32 times 3 times a to the power of 3. Now 32 times 3, 3 times 2, it's 6. This 3 times 3 is 96a cubed. Then that becomes the answer. Are you with me? So in a way, the aim here, when they say simplifying using laws of exponents, you are supposed to simplify into that part. All right, now let us continue here. As I say, this there is this activity. It says here, simplify the following using what? Laws of exponents. Now they have given you that part, right? And then you have to simplify. But as I told you, you need to collect like terms. So if I bring in this thing here to say you are given what? 2 to the power 4, but I'm going to rearrange. You see, I'm given 2 to the power 4, and then there is times 2 to the power of 3. Just look at that. I'm collecting the like terms, 4 and 3. Then the next one is what? Is 3 to the power of 3, which is times 3 to the power of 3 times, then let's focus on x, sums x, and then times, there is another x to the power of 5 there, times, and then we can focus on y squared, right, times y to the power of 5. I think that. So we have got this. So I started with the numbers and then the letters. Now if you are not given any power, you must know there is a hidden 1. Any number is to the power 1. Unless you are given the power, assume that it is 1. Then we can apply the law here. Remember, the base has to be the same, meaning 2 to the power 4 plus 3 only. It can only appear, apply in 2 alone. So you can apply the base there. Are you with me? You can't apply it in 3 because the base is different now. I can't say plus 3 here. Why? Because the base is 3. So it won't change. I'll write it as times 3 to the power of what? Of 3. You leave it like that. Don't force it. And then times, focus on the x. It's x to the power 1 plus 5. Is it making sense? times, now we are with y to the power 2 plus 5. Alright, then equal to, now 2 to the exponent 4 plus 3, it's 7, times 3 to the exponent what? 3 times x to the exponent what? 1 plus 5 is what? It's 6 times y to the exponent 2 plus 5, it's 7. So in a way, is 2 to the power of 7 times 3 to the power of 3, x to the power of 6, y to the power of 7. That is the simplified one that you can write. Okay, so that is that. Now let's look at B. When you look at B, it says we need to simplify. Remember the question, what I say? Simplify the following using laws of exponents. So if you look at B here, look at this. I'm given 6a squared times 2a to the power of 3. Can you try that on your own? I'm just going to give you a few minutes. What you do is you pause this video, just try it. What do you think will be the answer? Remember they said use the laws of exponents. So they expect you to use the laws of exponents. Can you try that and see what it gives you? Remember, pause the video, then you try it on your own. Now, if I was doing it, if you're checking your answer, it's same as saying 6 times a squared times 2 times a to the power of 3. Do you see that? Which is equal to 6, collect the numbers together, 6 times 2 times a squared times a to the power of 3. It's fine to make 6, you know, in your calculator. If you take your calculator, you will see that your calculator can express 6 as a product of its prime factors. So what you say 6 equal to, then you say shift. In your calculator, in that button B, there is an FAC, fact. If you press it, it will express 6 as a product of prime factors. It is going to give you, can you try that? You say 6, then you press equal sign, then you say shift, and then there is that button where there is B. It's FACT, fact. It's like this, FACT. If you press it, it is going to give you 2 times 3 times 2 times a squared times a to the power of 3. This is not necessarily what I'm doing, but I'll show you why I'm doing what I'm doing. Collect like terms, which is what? Which is equal to 2 times 2 times 3 times a squared times a cubed. Now, default means power 1, which is 2, 1 plus 1. I'm applying the law now, 2 and 2, then times 3 times a. Let's apply the law, a and a. What is the, when I'm multiplying, what do? You add 2 plus 3, which is equal to 2, 1 plus 1, it's 2 to the power of 2 times 3 times a to the power 2 plus 3 is 5. Remember, you are adding. Don't say 2 times 3, say 2 plus 3. Alright, then what do you have? Which is 2 squared is 4 times 3 times a to the power 5, which is equal to 12a to the power 5. Now, that is the answer, but I will say here, it was not necessary to do this step at this stage. Unless if it was big numbers, this step was not necessary, you know. So you can take it out, and you can take it out altogether. What you needed to do from here to get that answer, you could have gone straight to say 6 times 2, it's 12 a to the power 2 plus 3. That's where you apply the laws, which is equal to 12 a to the power 5. Are you seeing that? They expected that when you're using the laws. Now let's look at the other one here. Let me erase this part. Look at this question. It says simplify the following exponents, and I guess they didn't want you to use a calculator here. They are saying 2 to the 2 times bracket negative 2 to the power of 4. Now I just want to lay a little bit of foundation here, very important. I'll say NB. Now check this out. If I say minus 1 squared then I say minus 1 cubed, and then I say minus 1 4, and then I say minus 1 5. Let's use the calculator. I'm just going to use the calculator here, and you'll see the answers how they're going to check. If I say bracket minus 1 squared, the answer is positive 1. Don't forget. Now if I play back and then delete, I say minus 1 to the power 3. From positive is now negative, and then I put a 4 here, it's positive. I put a 5 here, it's negative. 1 does not change, but the signs. So here it was 1 negative 1 1 negative 1. So what are you noting? I want you to focus on this. If it's 2, it becomes positive. If it's 3, it becomes negative. If it's 4, it becomes positive. If it's 5, it becomes negative. Meaning, if the exponents, if I say minus 1 to the exponent n, and when n is equal to even number, if it's an even number, what will I get? So if minus 1 to the power n is equal to positive 1 if n is an even number. So minus 1 to the power m is equal to negative 1 if m is equal to odd number. Do you understand? So if it's an even number, it's 1. If it's a positive number, it's minus 1. But even in your own maths, how do you get the negative number? If I say minus 1 squared is equal to minus 1 times minus 1. Negative is equal to positive 1. But minus 1 cubed is equal to minus 1 times minus 1 times minus 1. So minus and minus positive, but you are left with 1 negative. Hence it's negative 1. So that's what happens. So don't forget, it's like that. So the same thing now, if I say here minus 4, minus 2 to the power 4, you don't worry with the power. First of all, you separate this like this. You are going to say, this is same as saying 2 times minus 1 to the power 4 bracket 2 to the power 4. That's what it simply means if you don't want to get confused. Alright, so this stage you could have left it, then it was going to be 2 times 2 to the power 4. So you can actually move from here to here, whereby you show us that you understand that if it was 4 and you recognize that 4 is an even number. So if 4 is an even number, this simply becomes 2 to the power 4. But if it was an odd number, it was still going to maintain as minus 2 to the power 5, for example. Then from here, 2 to the power 1, you may now use the law. 2 to the power 1 times 2 to the power 4, which is equal to what? 2 to the exponent 5. And 2 to the exponent 5 is what? Is 32. And you can test that with your answer here to say, is it possible for me to get 32 when I'm multiplying this? So let's test that with the answer, with the calculator. 2 times negative 2 to the exponent 4. Seeing that equal to 32. See that? Now let's do the last one, number 8. Number 8 is a bit trickier, but it's not really tricky. I wanted you to check this. Look at this number 8. It's not tricky, but it needs you to be careful there. It says 8 times 2 to the exponent 22. You can try this with the calculator. I just want to show you. Say 8 times 2 to the exponent 22 equal to, you see your calculator can't even calculate that. It's a big number, but you can use the laws. But what you do, as I told you, you can express 8 as an exponent. So what you do, you take the calculator, and then with the calculator you say 8 equal to, then you say shift, and then you press this button from A. There is a button here which is with the more like this button. It's at the bottom. It's called a FACT. If you press it, it will express 8 as a product of its prime factors. So it will give you 2 to the power of 3 times 2 to the power of 22. You see where the trick was? Now the bases are the same, so you say 2 to the power of 3 plus 22. Now don't lose it now here. Add that, say 22 plus 3. They won't pick up to say you're using the calculator per se, which is 2025. If you're confusing it, it's better to make sure that you get the right answer here. Remember, you can't test this because even your calculator can't give you the answer. So this is how you work this. Now let's look at says watch out for common errors with law 1. They are saying here with law 1, if you say, for example, x to the power m times y to the power n. For example, if you say 2 to the power of 3 times 3 to the power of for example 3 to the power of 2, this is not equal to 2 times 3 bracket and then you say 3 plus 2. No, it's not going to be the same. You can test it with the calculator. Let's test the first one. What is 2 to the exponent 3 times 3 squared? My answer is 72. See that? 72. What about this one? 2 times 3 to the exponent 3 plus 2. You see, I'm getting a very big answer. So totally different. So don't be tempted. Don't do that. Apply the law. Why is this wrong? The base. First of all is the base. The base here was supposed to be 2, and you don't multiply 2 times 3. You don't multiply inside. So remember, the law says 2 to the power 5 times 2 to the power of 2 equal to, if these are the same, you don't say 2 times 2, you just write 1 and then you say 5 plus 2. That's only that you need to do. So instead of, so they are showing you to say here, you don't say this is equal to 2 times 2 like this, and then you say 5 plus 7, so that you say 2 times 2, it's 4 to the power 12. You don't do that, it's wrong. Alright, and then the last one that is common also, this law, students always struggle. X to the power m plus x to the power n is equal to x to the power m plus n. You find students doing this. They will say, for example, a to the power m plus a to the power n. They say simplify. And then you find students saying a to the power m plus n. Something is wrong. When you see a plus here and a plus there, exponent is a plus, also between there is a plus, something is wrong. There must be a to the power n times a to the power n, then it's a to the power m plus n. See, the multiplication is addition on the exponents. Don't forget that. Only that. Okay, so if they come and say 2 to the power 5 plus 2 to the power 7, you cannot say it's 2 to the power 5 plus 7. You get that wrong. Test that with the calculator. You will see that it doesn't work right. Alright, now we are done with the first lesson on multiplication. Now the next lesson I want you to join me. We're going to look at law 2, which ensures that you cover the division. You don't want to miss this lesson. Remember guys, if you're not subscribed, it means you're missing out on a lot of lessons. Subscribe right now so that you can be notified every time I'm posting a new video. We've come to the end of our lesson. Don't forget, you can share this channel to your friends and your colleagues. Thank you.